Namaste dear children, I am Rekha. Welcome to my channel Rekha's Knowledge Hub. Today we will see Ncert Class 6 Mathematics Chapter 3 Number Play Part 1. Numbers are used in different contexts and in many different ways to organize our lives. Numbers help us in many situations. They keep things organized. We have used numbers to count and have applied the basic operations of addition, subtraction, multiplication and division on them to solve problems related to our daily lives. We use numbers to count things and also to add, subtract, multiply and divide to solve everyday problems. In this chapter, we will continue this journey by playing with numbers, seeing numbers around us, noticing patterns and learning to use numbers and operations in new ways. In this lesson, we will play with numbers, find numbers in our surroundings, look for patterns and learn new ways to work with them. Think about various situations where we use numbers. List 5 different situations in which numbers are used. See what your classmates have listed, share and discuss. So, you think of 5 different times in your life where you see or use numbers like in money, sports, cooking, phone numbers, etc. See what your classmates have listed, share and discuss. Compare your list with your classmates and talk about it. Numbers can tell us things. This part will show how numbers can give us information. What are these numbers telling us? We will try to understand the meaning behind some numbers. What are these numbers telling us? Some children in a park are standing in a line. Each one says a number. Look at this picture. Imagine kids standing in a row in the park, each saying a number like 0, 1, 2, etc. See this picture? Here we see 8 children. Above each child is a speech bubble with a number. See, you can see a number here. These numbers could mean something about them or their position. These numbers could mean something about them or their position. See, this girl has number 0. This girl has number 2. This boy has number 1. See, similarly 1, 0, 2, 1, 0. What do you think these numbers mean? We are being asked to guess the meaning of these numbers. The children now rearrange themselves and again each one says a number based on the arrangement. Now the children, they change their position. See this figure? This figure is different from the first figure. See, here the children, they changed their position, but each one says a number based on the arrangement. Did you figure out what these numbers represent? There is a hint here. Could their heights be playing a role? Yes, these numbers are related to their heights. A child says 1 if there is only one taller child standing next to them. See this child? He says 1. Why? Because there is only one taller child standing next to him. See, this girl is taller than him, but this girl, she is shorter than him. So, he says 1 because there is only one taller child standing next to him. Then, a child says 2 if both the children standing next to them are taller. So, when does a child say 2? A child says 2 if both the children standing next to them are taller. See this girl? She says 2. Why? Because both the children standing next to her. See, these 2 children, they are taller than her. So she says 2. Then a child says 0 if neither of the children standing next to them are taller. See this boy wearing pink shirt. See, he says 0. Why? Because neither of the children standing next to him are taller. This boy is shorter than him. This girl is also shorter than him. So he says 0. So if both neighbors are taller, the child says 2. If only one neighbor is taller, the child says 1. If neither neighbor is taller, the child says 0. So here the number represents what? How many taller neighbors I have. Try answering the questions below and share your reasoning. Can the children rearrange themselves so that the children standing at the end says 2? Is it possible to change their position such that the children standing at the ends say 2? See this picture. Can they change their positions such that the children standing at the end say 2? No, this is not possible. Why? A child at the end can have only one neighbor. So they cannot say 2. Ends have only one neighbor. So the highest number they can say is 1. Never 2. See this girl? She has only one neighbor. See this boy? He has only one neighbor. So they cannot say 2. The highest number they can say is 1. They can say either 0 or 1. If the neighbor is taller than him, then he can say 1. If the neighbor is shorter than him, then he can say 0. 2 is not possible. Can we arrange the children in a line so that all would say only zeros? See this picture. According to this picture, it is not possible to arrange the children in a line so that all would say only zeros. Why? Because someone in the middle will have always at least one taller neighbor. According to this picture, the children, they have different heights. But this arrangement is possible for a straight line. That is possible only if every child has the same height or there is just one child. See this picture here? All have same heights. So this boy will say 0. Why? The neighbor is not taller than him. This boy also says 0 because the neighbors are not taller than him. This girl will say 0 because the neighbors are not taller than her. Then see, this boy will also say 0. This girl will also say 0 because their neighbors are not taller. So we can arrange the children in a line so that all would say only zeros if every child has the same height or there is just one child only. Can two children standing next to each other say the same number? Is it possible for two children standing next to each other to say the same number? Is it possible? It is possible. How? We will see. See, we have 3 children here. This is child 3, then child 2, child 1. Consider this child 1. She has only one neighbor, child 2. This neighbor 2 is taller than her, so she will say 1. Then consider the next child, child 2. He is in the middle. Then for him, there are 2 neighbors. one neighbor is taller than him. So, he will say 1. Then, see the next child, child number 3. She has only one neighbor and that neighbor is not taller than her. So, she will say 0. Here, two children standing next to each other. They say the same number. So, it is possible for two children standing next to each other to say the same number. There are 5 children in a group, all of different heights. Can they stand such that 4 of them say 1 and the last one says 0? Why or why not? So there are 5 children in a group. Their heights are different. Is it possible for them to stand such that 4 of them say 1 and the last one says 0? We will see. See this picture. Here the children, they are standing in the order of height from left to right. See, this girl is shortest, that is H1. This H1 is less than H2. Then H2 less than H3, less than H4, less than H5. So, the children, they are arranged in the increasing order of their height. See the leftmost child, she has only one neighbor and that neighbor is taller than her. So what she will say? She will say 1. Then see the next boy, H2. He has 2 neighbors. One neighbor is taller than him. So he will say 1. Then next child, she has 2 neighbors. One is taller than her. So she will say 1. Then see the next child. She has 2 neighbors. One is taller than her. So she will say 1. Then see the last person. He has only one neighbor and she is shorter than him. So he will say 0. So from this we can conclude that the children can stand such that 4 of them say 1 and the last one says 0. For this group of 5 children, is the sequence 1, 1, 1, 1, 1 possible? Is it possible? This is not possible. Why? Because the tallest child will always have 0 taller neighbors. So at least one number must be 0. So you cannot have all ones. See this picture? See, the first boy, he has only one neighbor and she is taller than him, so he says 1. Then the next girl, she has 2 neighbors. One is taller than her, so she says 1. Then the next girl, she has also 2 neighbors and one is taller than her, so she says 1. Then the last child, he has only one neighbor but she is shorter than him. So he says 0. So this 1, 1, 1, 1, 1 is not possible. Next one is the sequence 0, 1, 2, 1, 0 possible. Why or why not? Yes, this sequence is possible. To achieve this, the children would need to be arranged in a way that the shortest child is in the middle. This sequence is possible. Then to achieve this, the shortest child should be in the middle. See this arrangement. Here the shortest child is in the middle. See the first child, he has only one neighbor and she is shorter than him. So he will say 0. Then the next child, she has 2 neighbors. One is taller than her. So she will say 1. Then the next child, the shortest child, she has 2 neighbors. Both are taller than her. So she will say 2. Then the next child, he has 2 neighbors. 1 is taller than him, so he will say 1. Then the next child, she has only one neighbor and he is shorter than her. So she will say 0. So this sequence 0, 1, 2, 1, 0 is possible. So the children would need to be arranged in a way that the shortest child is in the middle. The arrangement would be tallest, shorter, shortest, shorter, tallest. The shortest child in the middle has 2 taller neighbors. So they say 2. The 2 taller children at the ends have no one taller than them. So they say 0. The children next to the shortest child each have only one taller neighbor. Then we will get this sequence 0, 1, 2, 1, 0. How would you rearrange the 5 children so that the maximum number of children say 2? How do you rearrange the 5 children so that the maximum number of children must say 2? To say 2, a child needs how many neighbors? 2 taller neighbors. This can only happen to children who are not at the ends of the line. See this picture. If a child has 2 taller neighbors, then he can say 2. See the first child, he has only one neighbor and she is shorter than him. So he will say 0. Then the next girl, she has 2 neighbors. Both are taller than her. So she will say 2. Then the next child, she has 2 neighbors. Both are shorter than her. So she will say 0. Then the next child, she has 2 neighbors. Both are taller than her. She will say 2. Then the last child, he has only one neighbor and is shorter than him. So he will say 0. So we can rearrange the 5 children like this. Children, thanks for watching. If you like this video, please like, share and subscribe. We will see you in the next video. Thank you.